Okay, this is section 8.5, Recursion Part 2. I need to see in there, but in 8.4 we started looking at mixed recursion, and that gave us the foundation, and then now we're going to try to find the closed form for a mixed recursion setup. So for example, if we take this problem right here, we have our seed or our starting point, and then this is the formula to tell us what to do with our recursion. So if I write this out, this would be 3, then I do 6, and then that would be 10. Same one as what we did last time. So this would be 20 plus 4, 48 plus 4, and so on. Okay? Now what we want to do is find the fixed point of our recursion and call this P. Remember, for the fixed point, we let both the next term and our now term equal to x. And so if we have this, this is x is equal to 2x plus 4. Because what we want to do is we want to ignore this 3 and generate a sequence where every term is exactly the same. So if I solve this out, I get negative x is equal to 4, so x is equal to 4. Algebra let me down. Negative 4. So that means if I take this negative 4 and put it in here, that would give me negative 8 plus 4, which gives me negative 4 again. So it just keeps on going on to the same point over and over again. So that's called the fixed point. So in this situation, P is equal to negative 4. So we identified that. There we go. Then it says identify T1 and A. T1 is equal to 3. That couldn't be any harder. Then A for us, we have in mixed recursion, T sub n is equal to A, T sub n minus 1, and then plus some difference. And in this format, this is our A. And in fact, we'll call this B instead. Okay, and so what we do is we just plug these things in to this formula, and then we have our closed form for this. I'm not going to drive this here for you, but this is the formula that we use. So in this case, A is equal to 2. So if I write this, T sub n stays, because that's what we're trying to find. T sub 1 is specific, so that's 3, minus our P, which is negative 4. Yes, it's 3 minus negative 4, so that will be a plus. And then we take our A, which is 2, and raise it to the n minus 1. And then we add back the P value. So you just plug and chug those items. So to simplify this, 3 and this becomes 7, 2 to the n minus 1 minus 4. This would be our closed form. And another way that I say this is our explicit form. So this means that if I ask what's in the 50th locker, you can go straight to the 50th locker, plug it in, and boom, then we have our answer. Okay, go ahead and try this next one. Please pause this, and then I will go through and how to do it. Okay, did you try it? I sure hope so. So your first step, once again, is to find the fixed point. I hope you found that P is equal to 2. So if I set this up, T sub n, let's find all the other pieces too. So T sub 1 is equal to 6, and then my A value in this case now is equal to 3. That's the multiplier when we do our differences out. So we get T sub 1, which is 6, minus my P, which is 2. Boy, it's nice to write these things out when you're plugging all these things in. So then this would be 3 to the n minus 1, and then plus my P value, which would be 2. Simplify, this would be 4 times 3 to the n minus 1. When I write it like this, I can't multiply the 4 times 3. That's a mistake for some of you. Be careful. And so this would be my closed form. Now what we should do is probably check this. Why don't you go ahead and check it? Write out some of these terms and then see if, for instance, the third term worked. So if you checked this, I write out the first 3 terms. So this is my first term, second term, third term. First locker, second locker, third locker. So if I just check out what T sub 3 is, this is equal to putting in a 3 here, so 3 up here, so this would be a 2 for the exponent, and then we end up getting 38, which is the same as this term here. I think that's fairly credible evidence. Not fully. We should prove that by induction, but we don't do that in this class. But that's what we end up with. Okay? Then we want to find a closed formula for Zachary's annuity example in the previous example. So this is what we did in the previous lesson. We did the recursive formula, and we went ahead and found what the value was at a certain amount of time. So we want to do that down here, but we want to do this with a closed form. So we write out our formula again. Okay, so here's our formula, and then we have to go through the same steps to figure out what we have. Well, I use A sub n up there, but I could use T sub n or A sub n, doesn't matter. So if I find the fixed point would be x is equal to x times 1 plus 0.04 divided by 12 plus 50. Okay, so what we want to do is find this x. And this algebra isn't too bad, but let's try to figure out what happens here. If I subtract this from both sides, 1 plus 0.04 divided by 12, and over here, and it's the same algebra that you have any other time, so I'm doing this to both sides. But if I subtract x minus this x, well, this is 1x right here. So all I have is this additional amount, and it also carries the negative value. So over on this side, I'm going to have this negative 1x cancel out. However, I have negative 0.04 divided by 12 x left. So when I subtract this, I get negative 0.04 over 12 times x. That's what happens on this side. On this side, this cancels out, and I'm left with this equal to 50. So what I do with this one is to solve for x, I just divide both sides by this. So this would be 50. You could have changed this to a decimal by now if you wanted to. 50 divided by negative 0.04 divided by 12. So if you put that into your calculator, what you end up with is negative 15,000. That's a big p-value that we're looking at. So p is equal to negative 15,000. So I have my p. My first term is his $1,000 that he put in. So that's t sub 1. Sorry, I'm going across the bottom here. T sub 1 is equal to 1,000. And then my a value is going to be whatever we multiply by every time. So it's going to be this value here. That's my multiplier. So 1 plus 0.04 divided by 12. Some of you may get frustrated that I'm using that. I'd like you to see where it's from. If you want to change that to a decimal, no worries. But right now I'm going to use that. So if I plug this in, t sub n is equal to 1, t1, which is 1,000. Need the extra 0 there. 1,000 minus p, which means plus 15,000. And then I'm going to do a1, which is this value here. And then I'm going to take that to the n minus 1 and then put plus p. My p value is negative 15,000. There's my closed form. I can maybe clean this up a little bit. T sub n is equal to 16,000. And then this a sub 1. Okay, so we have this situation here where this is my closed form. Now if I plug in this 168, so I had 168 months from the last one, I plug it in. And when I do that, you can try this on your calculator as well. Please do. Make sure you can do this. If I plug this in, I get 12891. Uh-oh, that's not the same. Well, what's happened is that you haven't carried over that last month of interest. So this is similar to, we have to kind of finagle this a little bit. So you could have put in 169 and then subtracted out $50, or you could have put in 168 and then you need to multiply by your ratio. This 1.0003 and so on is the same thing as 1 plus 0.04 divided by 12. So you have to balance that out. So this value is equal to this value, but you have to do that last minute manipulation again as we showed you. And if you don't remember that, you look at the video, annuity 3 ways. All right, I hope this helps you. Write a little summary for yourself, some of the things that we went through, and then go through the book problems when you get to class. Thank you very much, and have a great day.